Okay. So last time I started to explain branch instructions, or what I want to do in this section, I want to explain how can we do something like that. If A is greater than 5, go to next. Okay. In any programming language, we are familiar with something like that. We have a condition. If the condition is true, you have to go somewhere, right? So how can we do something like that in assembly? Okay. So what I explained last time, guys, the way we have to do it is we have to use two instructions. Okay. Number one, we have to compare. You have to use compare or test instruction. Okay. To do subtraction. Okay. Also, I told you compare is similar to test. The only difference is it's going to compare to 0. Okay. So number one, you have to use compare instruction or test instruction to update the flags. After that, you have to use one of the branch instructions. Okay. So these two instructions together, they are gonna, using these two instructions together, we are gonna build two conditions, as you will see today. Okay. So also, if you go to the slides here, yeah, if you go to the slides here, guys, no, not here, sorry. Yeah, here, you can see I summarize all compare and test instructions here. Okay. So also here, I summarize all the branch instructions we have. Okay. I don't need to repeat that as you see here, guys, every instruction has two versions. One version with letter L and another version without letter L, as I explained last time. L here means long. It means you can branch anywhere. And I told you, just for peace of mind, you can use long all the time, and that's okay. Okay. However, today or maybe next time, I'm going to explain one instruction that's only short, cannot be long. Okay. But at least we have here, if you have the option between long and short, and you don't care too much about the efficiency, you can just use long all the time. Okay. Also, I told you we have here branch instructions. So these instructions are gonna branch or not based on the values of the flag. So I can branch if the 0 flag is 1 here, as you see here, okay? Or you can branch if the 0 flag is 0 and so on. Also, as I said last time, we have here a branch instruction. This one is gonna branch if greater, okay? If greater or same, lower or same. Here, so this one, if your numbers are unsigned, and this one, if your numbers are signed. So I'm going to explain today how can we use them. So they are here, yeah. Okay. Yeah, so they are here. Okay, guys. So I told you for signed, we use the English words greater, less, equal. For unsigned, we use the English word higher, lower, same. Okay, so here we use L. L means long, B means branch, if greater or equal. Okay, so number one, you have to compare, and then you have to use one of these branch instructions. They have to be coupled together. Okay, today I'm going to explain. So what I want to say is the following, guys. Very important. In assembly, you are familiar in C language, we have something we call if statement, right? You are familiar with if statement. Also, we have if else statement. We have if else if statement, and we have a switch and so on. So we have different statements, okay? In reality, in assembly, we don't have an instruction for these statements, okay? What we are going to do, we are going to use compare and the branch instructions as building blocks to implement these statements. You got what I'm saying? So what happened is in C language, when you did if statement in C language, when it is translated to machine code, this if statement is converted to compare and the branch instruction. Is that okay? So I want to show here, guys, I want to show you how can we use compare and the branch instruction to make these statements. You can even invent your own statement, okay? You got what I'm saying? So let's see how we do it. But keep it, I'm going to repeat it again because I know some students still confused here. Okay, look here, guys. In assembly, we don't have if statement. Okay, there is no instruction called if, but we are going to create it using compare and branch instruction, as you will see right now. Same thing for while, same thing for for, same thing for almost all the statements, if, else statement, and so on. So let's start with the first one. I want to do something like that. I want to do if I is a memory location, is equal to 1. I want to execute. This is the body of if, right? So you know from C language, we have a condition here. If this condition is true, we're going to execute the body of if. If the condition is false, so we're going to just branch to here. So we're not going to execute the body of if. So after you execute this one, either you are going to, if the condition, either you come this way, or you can just skip this part if the condition is false. Okay. So how can we do something like that? Using compare and branch instruction. That's what you are going to see here. For sure, I can't compare memory location to a number. We don't have this instruction. That's why I have to read I put it in register A, and then I'm going to do A or B, any other register, okay? Because we don't have compare for memory location to image event. Then, as you see here, guys, I'm going to say, this is an interesting point. Look how I made it, and then I'm going to tell you something important. Let's see how I made it. I'm going to say, compare A to 1, compare A to number 1. It's the same condition here. But if it is not equal, if A does not equal 1, please skip this part. Come to here. If it is equal, so that's how it is. If this branch, if this branch is true, okay, so the branch is going to be taken. If not equal, so the branch is going to be taken. If it is equal, so the branch is not going to be taken. So it's going to come this way. You got what I'm saying? So here, this one is going to branch if not equal. If A does not equal 1, so I'm going to skip this part. Is that okay? If it is equal, I'm going to execute S1. S1 is sequence of instructions similar to this one. Okay, listen to me. So if you look at the logic here and the logic here, they are the same. What do you mean by logic is the same? It means I'm going to execute S1 only if I is equal to 1. It's exactly the same thing. So I'm going to execute S1 only if A is equal to 1. It's the same logic, okay? However, I did a trick here. What is the trick? The trick is, here the condition was equal. But here I found it is better for me, or it's easier to make it non-equal. You got what I'm saying? But the logic is the same. So here I'm going to say, if not equal, skip this part. So what I want to say, guys, sometimes, if you make it the opposite of the condition, or the complement of the condition, whatever you want to call it, so sometimes the coding is going to be easier. But again, regardless how you program it, the logic has to be the same. What do you mean by the logic here? I mean, if A is equal to 1, if I is equal to 1, I have to execute S1, okay? Anyway, someone can ask me. So again, sometimes when I select here, this one is equal. Sometimes when I select not equal, if this one is greater, so sometimes I can do the opposite, less than or equal. Sometimes it's gonna make it easier. Sometimes, but the logic has to be the same. Someone can ask me, okay, but I don't want to follow this way. I want to make it equal. Yes, you can. This is just a programming. This is a building blocks. You can do it. However, as you will see right now, there is it's going to be like you have to add one more instruction, as you will see. Look how I'm going to do it. I'm going to compare E to 1. And if it is equal, if A is equal to 1, I'm going to go to body of F. And body of F is here. Okay, guys? Okay. Now, if it is not equal, what's going to happen? It's going to, this is a critical part. Let me make this one. Okay. So if A does not equal, guys, so I'm going to come to here, and this is the body of F. That's okay. However, if it is equal, it's going to come this way. So if you forget to put something here, it's going to come this way. That means no matter what, you are going to execute the body of F, which is false for sure. You got what I'm saying? Because if it is true, the branch is going to be taken, it's going to come to here. If it is false, if it is not equal, so also it's going to come to here. So I'm going to execute this one no matter what. For sure, that's not the same logic. Okay, that is why you have to put this instruction here, unconditional branch. Please, if you come to here, it means it is not equal, and you have to skip this part. Okay, guys. Again, what I'm saying, I programmed it using 2 ways, as you see here, 2 ways. Both of them, so this case and this case, both of them are doing the same logic like this one, same logic. Okay, what logic? I'm going to execute S1 only if I is equal to 1. Otherwise, don't execute it. Both of them are doing the same thing, right? However, this one may be just when I did not equal, I found it's just straightforward, okay? But here, you have to put this one. Don't forget, this is unconditional branch, guys, okay? So that means if it is not equal, I'm going to come here, and this one is going to let me skip this part. Very important, common mistake. Many students forget this one. Many students. So this is a common mistake. If you do this one, if you get this one, no matter one, I'm going to come here because if the branch is, if the branch is not taken, so I'm going to come this way anyway. Is that okay, guys? Any questions? Very easy, right? Let's have more examples. I want to do something like that, guys. If else statements, okay? I want to do if A, register A is equal to 1, I want to execute S1. Else, I want to execute S2. Is that okay? You know from C language, is there any way I can execute both of them? No. The condition either true or false. Nothing in the middle. Either true or false. Condition is true, I'm going to do this guy. The condition is false, I'm going to do this guy. So there is no way you are going to execute both of them. Okay, either this one or this one. Is that okay? Look how I can program it using assembly. Look here, guys. I'm going to compare A to 1. I'm going to compare A to 1. Then I'm going to say if it is not equal, if A does not equal 1, so go to else. So I'm going to, and here, so I'm going to, if A does not equal to 1, similar to this one, if A does not equal 1, you have to execute else. So I'm going to come here, and then I'm going to go to else. Guys, please understand me. Else here, just a name. This is not a keyword. Else here in C language, it was a keyword. You understand what I'm saying? So else here, this is an instruction. Here, just a name, any name. That's why I start with underscore here, right? Just any name. Okay, so don't be confused. Okay. So here, what's gonna happen if A does not equal to 1? I'm gonna go here to execute S1, and then I'm happy. Okay, I'm happy. Okay. However, if A is equal to 1, because you know this branch, if it is equal, so it's gonna come this way to execute S1. Is that okay? Again, if it is not equal, I'm gonna come here to execute S2. I'm very happy. If it is equal, I'm gonna come here to execute S1. This is similar to this one. However, okay, look at this one here, guys. However, what's gonna happen is here, because else is an instruction. If it is, this is a structure, this is a statement. That's why once you execute S1, automatically it's gonna go out. You don't need to say go out, right? In C language. Here you have to say, because I'm creating this structure. We don't have this structure in assembly. I'm creating it. That is why once I execute S1, it's gonna continue. You understand? So the assembly language is gonna continue, right? So that's why you have to write here instruction to skip this part. So that means if it is equal, so once you finish this part, you have to skip this part. Is that okay, guys? Again, very important. In C language, you didn't need to do that. I didn't need to say once you come here, skip. Why? Because this is one statement. Okay. Here we don't have this statement. I'm creating it. So I have to use the building blocks to create it, right? So that's why what's going to happen, you have to use branch. This is unconditional branch. So every time you come this way, okay, man, you have to skip this one all the time, because once you could execute S1, you should not execute S2. Any questions? Okay, guys. Again, I just selected here. You can do it in, again, this is a programming. You can do it in different ways. So I did it here with not equal. You can do it with equal. You can, okay. But in this case, if you want to make it equal, so this one should be the body of F. The body of F has to be here, right? And else has to be here. So this should be else here, okay? To have the same logic, okay? Again, what you can program it in different ways. That's okay. However, what's important, you should have this logic. Any questions? Again, this topic, guys, is very, very important. We're going to use it all the time. And by the way, the coming lab, in my opinion, is one of the most difficult lab. It's not because it is difficult, but because this is the first time you are gonna write like a big program, okay? But it's not difficult if you understand this topic, okay? Anyway, now I want to do something else. For example, here, guys, in C language, you do something like that, condition like this one. Do you remember in C language? So here I have two conditions, okay? If A is equal to 1 and, so this one means and, logic, okay? This is and B is greater than A. So how this one works in C language? Very simple. All what you have to do, guys, in order to execute S1, the two conditions must be true. Both of them should be true. Is that okay? Okay, great. We have another one. You remember this one? Or. How this one works in C language? Very simple. In order to execute S1, one condition should be true. Enough. One is enough. But if both are true, that's okay. But just at least one is true, right? So in order to execute S1, at least one of them is true. So I want to teach how can we do something like that in how can we do something like that in C language in assembly. Is that okay, guys? Let's see how can we do it. Okay. So again, you can see the logic here in two different ways. Okay. Look, and then you can use whatever. Both of them are correct. Both of them are the same logic. And then you can use the logic you like, okay? Or look here, guys, because the exam is open book, you have the slides. So all what you have to do, guys, is if you need if statement, you can just go to the slides. You see how I made it, and you made something similar to it, like. But anyway, but I want you to understand how I build it, how I made it, okay? But anyway, so for example, I can say this one, guys, this logic here. Execute S1 if A is greater than 1 and B is greater than 8. So this is one logic. So this is one logic, okay? That means I have to check, I have to make sure both of them are true in order to execute S1. Okay, that's one logic. There is another logic. I can say, don't execute S1 if the first condition is false or the second one is false. Both of them are true, but two different logics. Okay, guys? So I'm gonna use this logic in the programming, because again it's easier. You know what you mean exactly. I'm going to tell you what I mean. I'm going to check the first one. If the first one is false, go out, leave. I don't need to continue, leave. Very easy. You can make it easy. That's exactly what I did. Look here, guys. I'm going to compare it to 1. If it is not equal, that means now I'm checking the first condition. If the first condition is false, don't continue, leave. That's what I did. Leave, go out, skip out. Make sense? If not, so I'm gonna come here. So the only way you are gonna come here if this branch is not taken. So I'm gonna come here only if this branch is not taken, and this branch is not gonna be taken if A is equal to 1, if this condition is true. Is that okay? So now, if I come this way, that means the first condition is true. This one here is true, right? But I flipped the condition. I make it non-equal. I flipped it, right? So anyway, so if A is equal to 1, I'm gonna come here. Again, the best way, I know this part is a little bit confusing, this part, but the best way to understand using arrows, as I explained arrows here, okay? This is the most difficult, confused. It's not that I don't want to use, nothing is difficult, but it's a little bit confusing to students. And most of the mistakes the students make usually in these branches, okay? But if you make errors as I did here and see what is the logic, it's gonna be easy, okay? So what I'm saying here, I'm gonna check the first condition here. If it is not equal, just go out, I'm done, right? If it is equal, if A is equal to 1, okay, so this one is okay. Is this not enough to execute S1? I have to look at the second one. So the only way to come to here when A is not equal to 1. Now, I'm going to look at the second condition. Look here, guys. I'm going to compare B to A. And then I'm going to say if it is less or same. So if this one is false, go out. Okay. So when I implemented it, guys, I looked for the opposite of this one. I did the opposite of this one. I said, not I did, but as you see here, if the first condition, if B is not greater here, means less than or equal. The opposite of this one here, if it is greater, so the opposite of less than or equal. Okay, so I'm saying if B is less than or equal 8, just to go out. You don't need to continue. Is that okay, guys? So if not, so you have to come this way. Let me tell you the conclusion. Very important conclusion. Look here, guys. The only way I can come here, the only way I'm gonna come here is this branch is not taken and this branch is not taken. Makes sense? So when I come here, no, it's not taken. Come here, no, it's not taken. So that's why I'm gonna come here. Is that okay, guys? You know, if the condition is true, the branch is gonna be taken. If not, so it's gonna go to next one, no branch. Okay. So the only way I can come here if this branch is not taken and this branch is not taken, because if any one of them is taken, I would come to here. Make sense? And the only way that these two branches are not taken when A is equal to 1 and B is greater than 8. And that's what I want to do, right? Right? So here's the only way I'm gonna come here if A is equal to 1, so this one is not gonna be taken. I'm gonna come this way, and B is greater than 8. So I'm going to come this way to execute as well. Any questions? Yes. Number one, I did the same logic. I did the same logic like this one. What logic? I'm going to execute this one only if the two conditions are true. So I did the same logic, right? But when I did it, I found it's easier for me to say to use this logic. The second one. Don't execute this one if the first condition is false. So I'm going to check the first condition. If it is false, go outside. You get what I'm saying? If it is true, so check the second one. If it is false, go outside. You get what I'm saying? Again, this programming, you can do it in different ways. But what I said, and you have to pay attention to this, sometimes it's easier for me to do the same logic by doing the opposite of the condition. Sometimes it's better for me to do the same condition, not the opposite. You get what I'm saying? As you see now. So it depends. Sometimes you can think about which one is easier for you. You get what I'm saying? Let's see one more. Here, guys, I wanna if A is equal to 1 or B is greater than 8, I want to execute S1. Is that okay? As I told you, what this means in C language, it means I want to execute S1 if at least one condition is true, at least. If both of them are true, that's okay. I don't need. So what happens here, guys, I'm going to check the first condition. If this one is true, okay, so that's enough. I don't need to go and check the second one. I don't. You got what I'm saying? Only I'm going to check this one only if the first one fails. Because I only need one, right? So if this one is true, that's enough. I don't need to go and check the second one. Is that okay? That's exactly what I'm going to do right. Let's see how I did it. Look here, guys. What I'm going to do right now. I'm going to compare it to number 1. If it is equal to 1, look here. What I did, it's the same condition. I used the same condition, equal, not the opposite. But anyway, so now that means the first condition is true. So what should I do now? The first condition is true. Okay. So I don't need to check the second. So here I check one condition. Here I check the second condition. Is that okay? Now I'm going to check the first one condition. Compare it to 1. If it is equal, okay. I don't need to check the second one. Please go to body of F. And this is the body of F. Is here. Is that okay? That's enough. However, if this condition is false, so if A does not equal to 1, so this branch is not going to be taken. I'm going to come here. Once I come here, I have to check the second one. When I check the second one, I'm going to repeat the same thing again. What I'm going to do, guys, here, again, if B is greater than 8, B is greater than 8, so you have to come to here. Is that okay? This is a common mistake. Please don't do it. This is a common, I'm quite sure. If you listen to me, you are going to waste. Sorry, you are going to, you're not going to waste. You are going to save a lot of time. Why? Because if you make a mistake, your program is not working. So you are going to spend hours to look where is the problem. Sometimes the mistake in your program, you forget something like this one. This is a very common mistake. Okay, guys. So what I'm saying I'm going to check the first condition. It is true. So just come here. If not, So check the second one. If it is true, just go to the body of if. If this condition is false, branch is not taken, it's gonna come this way. If this one is false, the branch is not taken, it's gonna come this way. So the only way I'm gonna come here if when the two conditions are false, is the only way. Okay, many students, please listen to me. Okay, I want to save your time. Or also I want to save your frustration, because I know when there is a mistake and you can't find it, you'll be frustrated. So okay, so you have to be smart. To be smart, you try to avoid making mistakes and just make mistakes, and then with if you just better if you can avoid mistakes, it's much better anyway. Okay, so what I'm saying, if you come here, guys, so you please don't forget this one. Okay, so here I have to skip. I have to skip to here. Is that okay? Because when the only way I come here when the two conditions are false, so I have to skip. I have to come to here. I should not execute the body of if. You know what happens if I forget this one? Can anyone guess if I forget this one? Yes, that's true. I'm gonna always execute S1 no matter what. If the first one is true, I'm gonna come here. If it is false, I'm gonna come here. If this one is true, I'm gonna come here. If it is false, also I'm gonna come here. So no way. So all the time you're gonna come here. You get what I'm saying? That's why very important to put a branch here to skip this one. Unconditional branch. Unconditional. Once you come this space, so once you reach to this point, without any condition, you have to skip. Any questions? Great. So I'm going to explain one more or two more before I go to loops. So let's do, for example, if statement. Okay. So let me explain in C language how it works. In C language, guys, it works this way. If A is less than 0, I'm going to execute S1. If the first condition, this is how it works in C language. We're going to check the first condition. If the first condition is true, I'm going to execute S1 and then leave. Okay. If not, if the first condition is false, so I'm going to check the second condition. Okay. If this one true, I'm going to execute S2 and then leave. If this one is false, so I'm going to go to the next one. I'm going to check the next one. If this one is true, I'm going to use S3 and then leave. If this one is false, so I'm going to go execute else. Okay. So I'm going to execute else. I'm going to execute else only if all these conditions are false. If all of them false, I'm going to go to execute else. There is no way you are going to execute more than one statement. There is no way, only one. Yes. Switch case, or what do you mean? Yes, that's what I'm doing here. Switch case. Okay, that's a very good question. Listen to me. The beauty of the assembly language is you have the building blocks. You can use the building blocks to create any statement you want. You know what I'm saying? In C language, you are limited. So they give you a certain statement you have to use, right? Here you have the building blocks. You can create whatever statement you want to do. You can invent, in C language, they invented if else, a switch case. You can invent your own statement and you can implement it using using the building. You have the building blocks now, right? Again, guys, I'm gonna repeat it. This is a reality. Assembly is a reality, because in C language, just when you did something like that in C language, it's converted to something like that, because this is the only thing machine can understand. This is the part you did in C language. That's what you was able to see in C language. But this is the hidden part. You didn't see this part when you took the C language course. You didn't see this part, right? In this course, you are going to see it. So you understand what I'm saying? So that's what you wrote in C language, but it has to be converted to this one. Okay, that's what the compiler did. Anyway, so let's see how can we do. Again, no matter what, you should execute only one statement. Okay, so how can we do something like that here? Okay. Again, as I told you before, sometimes if I make a condition less or if I use the same condition, sometimes it's easy. Sometimes if I use the opposite of this condition, this one is less, so the opposite of is greater or equal, right? So sometimes it's easier to me. But regardless of how you implement it, well, I'm going to do the same logic as I just said. Anyway, so let's see how can we do something like that. Look here, guys. Number one, I'm going to check the first condition. I'm going to check the first condition. Look what I'm going to do. I'm going to say, this is 0. I'm sorry, this is 0 because this is 0. Or if this is 10, you have to make this one 10. Okay, so let's see, for example, this is 0 and this is 0. Okay, so now I'm going to do the first condition. I'm going to say, compare A to number 0. Right, guys? If it is not equal, if this condition is false, false means greater or equal. If it is greater or equal, please go to check F2. So it's like, this is one block for F1. This is one block for, this is the first F, second F, and this is else. You got what I'm saying? So what I'm, as you see here, guys, I'm going to say, if A, look at this part here, if A is greater than or equal 0, that means this condition is not true. Please go to check, come here to check the second one. If not means, so the branch is going to come this way, and it's going to come this way if A is less than 0. So if this condition is true, if A is less than 0. So here I'm going to put the sequence 1, and then you have to branch it to the end. Please don't forget this one. Please, you're going to waste a lot of time. Okay, if you forget this one. So what's going to happen? If this condition is true, I'm going to come this way, execute S1, and then go to the end, go out. Make sense? Now, if the first one is false, first condition is false. So now it is greater or equal instead of less. If it is greater or equal, so I have to come to here. I'm going to come to here to check the second one. That's what I'm doing here. Here I'm going to, and then I'm going to repeat the same idea again. I'm going to repeat it again. Look. So now I'm going to compare A to 5. So now I want to check this one. I'm going to compare E to 5. If it is less or equal, okay, please go to check F3. Right? Again, this F1, F2, F3, just names, like your name, any name, right? So here, so now, if this condition is false, please come to here. If it is true, if A is greater than 5, so I'm going to come here. Then don't forget this one, please. So this one is going to give me, I'm done. So once, that's why you see here, guys, I'm going to repeat this branch here. I'm going to repeat it, right? Why? Because once I decide to execute S1, I have to go out. Or execute S2, I have to go out, and so on. Okay. So now I'm going to repeat again. I'm going to come to here, guys. I want to check if this one is false. So if this condition is false, so I'm going to come to here to check this one. Okay. Again, what I'm going to do here, guys, as you see, I'm going to compare A to 6. And if it is equal to 6, equal means this condition is false. What should I do? Please go to else. That's what I did. So I'm going to say if it is equal, please go to else. Go to else. Okay. If it does not equal, so I'm going to come this way, and then I'm going to skip this way. Okay, guys? Any questions? Okay. Next one is switch case. You remember a switch case, okay? In switch case, as you know, we have here a variable, or sometimes you have a mathematical expression. You have to use the word switch. You have to put braces this way. You have to put here case, for example, case 1, case 2, and so on. And the end, you can put here a default. Okay. So what happens, as you know, based on the value of the variable here, if this variable is equal to 1, so I'm going to execute S1, and then I'm going to break, go out. Okay. So it's like I want to, based on the value of the variable, if the variable is equal to 1, I'm going to execute S1. If the variable is equal to 2, I'm going to execute S2 all the way until if the variable does not equal any of these values, so I'm going to go to default here. So if it does not equal any of these values, okay, and again, similar to what I explained before, once you execute one sequence, you have to go out. You should not continue. Okay. Any questions? How can we do it? How can we do it using assembly? Again, You have to use compare and branch. These are your building blocks. Compare and branch to create the same logic, right? Let's see how I made it. So look here, guys. Number one, as you see here, I'm gonna compare this is together. I'm gonna compare A to 1. If it is equal, please go to case 1 and case 1 here. So here I do all the comparison here and all the cases here, as you see. Okay, so I'm gonna here check. So I have to check compare to 1. If it is equal to 1, so go to case 1. Once you go to case 1, I'm gonna execute S1 and then go outside. I'm done. Please don't forget this one, please. You're gonna waste a lot of time, okay? Because once I execute this one, I have to go out. Otherwise, if you forget it, so it's gonna continue this way. Even we put it even in C language, like break. This is like a break, you go out, okay? Anyway, okay, guys? So now, if it is not, so if A does not equal to 1, so the branch is not gonna be taken, so I'm gonna come this way. So the only way to come to here, when A does not equal to 1. So now I'm gonna try with 2. So I'm gonna compare A to 2. If it is equal, please go to case 2, right? If it is not, so the only way when I come here, that means it is not 1, it is not 2. Why? Because if it is 1, I would come to here. If it is 2, I would come to here. The only way I come to here, if this branch is not taken and this branch is not taken. And this can happen only when A does not equal to 1 and 2 also does not equal to, A does not equal to 1 and it does not equal to 2 as well. So if I come to here, guys, that means please go to default. Go to default here. Any questions? Is that difficult? Okay. So in the coming lab, you are going to do a lot of if statements, something like that. Also, here in the second part of this section, I want to explain loops. You remember in C language, we had 2 types of loops. We had for loops and we had while loops. And they told you this is a structure of for loop. Remember, for I is equal to 0, I is less than 10, I plus plus. Okay, and they told you this is you have, in order to make for loop, you should have a counter. This counter is I, right? This is the initial value for I. So in the first iteration, I is equal to 0. Every iteration, I'm going to increment I, right? This is how C language works. So in every iteration, I'm going to increment I. And then I'm going to keep looping, and every iteration, I'm going to increment I. I'm going to keep looping until this condition is false. As long as it's true, I'm going to keep looping. So in this case here, guys, I'm going to start I from 0 until 10, less than 10. So what's going to happen? I'm going to loop from 0 to 9, right? So 0, and then I'm going to check, is 0 less than 10? Yes, continue. Now I is 1. 1 is less than 10? Yes, continue. So I'm going to keep looping this way until after it is 9. So I'm going to come here, increment. Now it's 10. Is 10 less than 10? No, go outside. Is that okay? So this one is going to branch from 0 until 9. Okay. Again, you can do it using increment this way, or if you want to do it, you can do it using decrement this way. So I can start from 10, and every time I can decrement. Again, whatever you want. Both of them in this case should be the same. But sometimes you wanna start from the small number and then grow to big number. You wanna start from the big number, you wanna decrement it, whatever you wanna do. So here in the first iteration, I is 10. Every time I'm gonna decrement I. Once I is equal to 0, I'm gonna go outside. Okay, guys. Any question about for? Very easy, right? For loop, very easy. Now, while loop. While loop is somehow different, guys. You have to put here while, and then you put here a condition. And then I'm going to keep we are going to keep looping as long as the condition is true. So here what's going to happen is that first, when I come here, I'm going to check the condition. If the condition is false, I'm going to go outside. Okay. Condition is true, I'm going to come here. Then go back, check the condition again. False, go outside. True, make one more iteration. Go back, check again, and so on. Is that okay? How many times you have to loop? I don't know. Maybe one time, maybe two, maybe 1 billion, 2 billion, 1 trillion, whatever it is. As long as you are gonna stop looping when the condition is false, right? So this is while loop. Also, you are familiar with something else like do while. I think you have to put your semicolon. You can check this one. Okay, so you have do while. It's the same idea. While loop is similar to do while is similar to while loop, but the only difference is here you are gonna execute first and to check, right? So here I'm gonna make one iteration, then it check. If this one false, go outside. Here, in the first time I'm gonna check this one false, go outside. So they told you in C language, the main difference between them, do while can guarantee that you are gonna execute at least one. If the condition is false in the very, sometimes in programming we need something like that. Sometimes in programming I need to execute it at least one, right? Even if the condition is false in the very beginning, right? So here, so I'm gonna execute this one first, okay? So at least to do while, I'm gonna execute first and then I'm gonna check. So do while can make sure you at least you can at least you are gonna execute it only one. But here, when I come from the beginning here, once this one is false, I'm gonna go outside. One more thing, you have question? Okay. So one more thing, they told you in C language when you should use for and while. They told you if you know during the programming, if you know how many iterations you want to make, use for. For example, I have array. This array has 100 elements. 100 elements. Is that okay? So, and I have to go through all the elements. I have to scan all the elements. Okay. So I have to do 100 iterations no matter what. So in this case, use for. So during the programming, if you already know how many iterations you have to make, so just use for. For is that, okay? In another example, if you don't know, right, how many iterations you are going to make, for example, you are asking the user to give you a number and tell the user when you are done, please hit enter, okay? So maybe the user is going to give you 2 numbers and then enter. So there is a condition. Let me give you another example. I have an array and I want to ask you, is there a negative number in the array? Do you need 4? No, I don't need 4 because once I find negative number, I'm gonna leave. I don't need to scan all the elements, right? So I'm gonna start from here, right? Are you negative? Yes. Just leave. Don't continue, right? If negative, no. So you have to check next one, and so on. So anyway, so usually 4 is used if you need a fixed number of iteration to make. Usually, okay. And while is used if you don't know how many iterations during the programming, right? You want to keep looping until a condition is true. Okay, guys? So now, how can we do for loops here in assembly and while loops? Okay, look here, guys. We're going to do for loops and while loops. We're going to use 2 different approaches. One approach, we have some instruction for looping. Using loop instruction. Okay, guys? So this is one approach. I'm going to explain. There is another approach. You can use the building blocks. We have. So you can use compare and branch instructions to build for loop, build while loop, and so on. As I'm going to explain right now. You get what I'm saying? So we have 2 different approaches. I'm going to tell you what is the advantages and disadvantages of each one. So there are 2 ways. One way you can use, we have loop instructions like these ones, as I'm going to explain. Also, you can make the for while loop by yourself by using compare and branch instruction. Okay. So I'm gonna adjust. I'm gonna explain one part because that's what we need in the lab. So I'm gonna explain it first before the other parts. Okay. So for example here, because that's what I'm gonna start with while instead of for, because that's what we need in the coming lab. Okay. So in the coming lab, guys, here we are gonna need while. So that's why I'm gonna explain while here. Okay. I just want to tell you here, as I have just explained, while you have condition. If this condition is true, right? So the C language is going to replace it by number 1. So the C language is gonna calculate this one. If it is true, it's gonna replace it by number 1. If it is false, it's gonna usually replace it by 0. Sometimes it's not 0, other number, I guess. So anyway, so usually you have 1 or 0. Okay, but anyway, so what I'm saying here, as you will, if you want to make infinite loop, and that's what we're gonna do in next chapter. If you want to make infinite loops, yeah, infinite loops, so you can put here a condition that's always true. So I can say while 2 is equal to 2. It's funny, right? Because 2 is always equal to 2. So this is a condition that's always true. Or you can simply just put 1 here, 1. Because when you put 1 here, that means it's true all the time, true. So something, that's how can you create infinite loops. What I want to show here, guys, I wanna explain how can you do, I want to do something like this while loops. Again, remember, guys, in assembly, we don't have while instruction. We don't have while instruction. I'm creating the while instruction. Okay? Let's see how can we do it. Look here. So here I'm going to say, I want to do something like that. While a does not equal to 0, please keep looping, right? So this is how I can do it. Look here. First, I'm going to compare e to 0, right? If it is equal to 0, so this condition is false. Okay, guys, please listen to me. So here I'm going to check if this condition is false. If this condition is false, please go outside. Is that true? If not, if this condition is true, so I'm going to come this way. I'm going to execute. Once I am done, please unconditionally come back to check again. Unconditionally go back to check again. The only way, so every time you come here, this one unconditionally come back. Come here, unconditionally come back. The only way you are going to go outside is when this condition, when this condition here is false, when a is equal to 0. Okay, when a is equal to 0. So the only way you are going to go outside when a is equal to 0, and that's what I'm doing here. I'm saying compare e to 0. If it is equal to 0, go outside. Very easy. Make sense, guys? Any questions? Make sense? Okay. Very important, guys. Please listen to me. Look what I'm saying here. I want to make it easy for you. What I'm saying, here's a condition was not equal. Here I did the opposite, equal. Is that okay? Now, what if the condition, for example, was greater? Is it difficult? It's the same thing. But what you have to do here, you have to do the opposite of greater, right? So I am going to say here, branch if less or equal. Okay? If it is less or equal, go outside. So I want to just generalize it. Generalize it. You understand what I'm saying? So here, whatever the condition you have here, I'm going to do the opposite here. So because I'm not going to execute the what, I'm not going to execute the body of while when it is less than or equal. So I'm going to look for less than or equal. Is that okay? If this one is less or equal, okay. So this one has to be greater. So I'm going to say branch if greater. Go outside. Make sense? Yes, I give you example on does not equal, but you can generalize it for any other condition here. Or equal, for example, it can be equal. For example, if I tell you equal, if equal, that means I'm going to say here not equal. If not equal, go outside. If a does not equal to 0, go outside. If this condition is false. Any questions? Make sense? Okay. What I want to teach here, guys, we have 2 instructions. This instruction we call them bit condition branch instruction. So now I'm going to teach 2 instructions. One is called BR, CLR, branch if bits are clear. Clear means zeros. The second one, branch if some bits are set, are ones, right? So now I want to teach what we call bit condition branch instructions. So what's going to happen here? We have 2 instructions anyway. This instruction should check some bits in a memory byte, or and then it's going to branch if these bits all of them zeros or ones. Can you clarify? Yes, I can clarify. Look here, guys. You have a memory byte. Number 1, you have a memory byte. I want to branch when a certain bits, all of them are zeros or all of them are ones. This one is going to branch. If all of them are zeros, this one is going to branch if all of them are ones. So these two instructions are going to check some bits in a byte. Going to check some bits in a byte. And then the branch is going to be taken if these bits are zeros or ones. Why sometimes you need to check some bits in a byte? Oh, there are many reasons. I'm going to explain later. But let me now focus on how it works. And then I'm going to explain how it is useful. Okay. So let's see here. For example, I have a byte here. This is a byte. Okay, a memory byte. I want to branch if these two bits, certain bits, can be 1 bit, can be 2, can be 3, any bits, or this bit. You have to tell me which bits you want to check, right? For example, in this case, I want to check these 2 bits. If these 2 bits are zeros, so I want to branch, you have to use this one. If these 2 bits are set, so I'm going to branch, you have to use this one. Okay, guys? So how can you use it? I'm going to tell you how we can use it. So again, what I'm saying, I'm going to teach now 2 instructions. In these 2 instructions, you are going to check a byte in memory, a memory byte. You are going to check a certain bits in this byte. And if these bits, all of them are zeros, this one is going to branch. If not, if anything else, if not means if all of them are not zeros. So for example, 001 or all of them are ones, anything else, any other case. Okay, for example, here, so here what I'm saying, 00. So if I use this one, branch if clear. So this one is going to branch if both of them are 00. In any other case like 10 or 01 or 11, so the branch is not going to be taken. What you mean the branch is not going to be taken? It means I'm going to execute the next one, next instruction. Okay, so either I'm going to branch or just execute next one. Okay, so this one is going to branch if all the bits are zeros. This one is going to branch if all the bits are ones. Okay, let's see how we can use it and how we can write the instruction and how can use it. Okay, so in this instruction, actually you have to put here 3 operands, and this is one of the very few instructions that needs 3 operands. As you see here, guys, I'm going to say branch if clear. Okay, and then here the first operand here, you have to put the address of the memory byte. So you have to put address. Again, this address again can be any format I explained before for memory, 1,x, it can be a,x, any address here in memory, any format should be okay. Okay, this is the first operand. So the first operand, you have to tell me which byte in memory. Okay, so this one is going to give me the byte. Which byte? Next one, we call it a mask. Okay, in this mask, you have to tell me which bits in this byte you want to check. Which bits, right? For example, so how we can do it? Very simple. So here, this number can tell me which bits you are interested in. Okay, very simple. How I can do it? I'm going to tell you how. For example, this is 8 bits. Okay. The bit you want to check, you have to put 1 in the position of this bit. So if you are interested in this bit, if you want to check this bit, I'm going to put here 1 and 0 everywhere. Here in the mask, I'm talking about the mask. So this mask should tell me which bits. Okay. So in the positions of the bits you want to check, you have to put number 1. That means if you make the mask this way, 0, 0, 0, 0, 0, 0, 0, 1, that means I'm going to branch if the first bit is 0. Okay. If you put the 1 here, that means you are telling me I want to check this bit. If you put the 1 here, I want to check these 2 bits. If you put the 1 here, so I want to branch when these 3 bits are zeros. Okay, guys. So the bit you can check 1 bit or more. Okay, you can check 1 bit or more. The bits you want to check, you have to put 1 in the position of this bits. Okay, again. So this one should tell me which byte in memory I have to work on, which byte. This one should tell me which bits you want to check, right? And then this one is going to branch if these bits in this byte are clear. Where it's going to branch? This is the third one, right? I'm going to give you examples. Again, so this one is similar. So this one is exactly same thing, similar. Everything is similar. The only difference, this one is going to branch if the bits of interest are clear. This one is going to branch if the bits of interest are set, are once. Okay. So let me give you examples. The best way you should understand it by using examples. Look here, guys. If I want to do something like that, I'm gonna say here again. I'm gonna use here. I'm gonna use a label. This label I'm gonna call it loop. Okay. Again, guys, please. Loop is not an instruction. It's not a keyword, right? It can be any name. It can be your name. I just use the word loop. Okay. I'm not sure if it's gonna Kudur is gonna, if it doesn't accept it, you can put underscore here or whatever. Anyway, so just a name. And then look here how I make this instruction, guys. I'm gonna say branch if set. Branch if set. And then you give me address. So you are telling me I want to work in the memo in the byte in the location number 66. So this is the address. This is the memory. It cannot be anything else. It cannot be immediate value. It cannot be a register. It's only always memory. So once you see number here, that's a memory. So I'm gonna go to the location with the address 66. Is that okay? So I'm gonna work on this byte. So you told me which byte. That's okay. Is that enough? No, it's not enough. You have to tell me which bits. I have to check because this instruction is gonna check bits. So you have to tell me which bits. So what's gonna happen here, guys? Here you are gonna give me the mask. This mask should tell me which bits, for example. And again, this mask, you can put it in any format. You can put it, for example, I can put %, as you see here, 1000, or I can make it 80 this way. So when you put the mask this way, you are telling me I want to check bit number 7. You want to check bit number 7. Is that okay? And if bit number 7, this one, I want to check this bit in this byte. And if bit number 7 is set is 1, please go to loop. Okay. So what this instruction is gonna do, guys, as based on what I explained here, we're gonna every time we come here, I'm gonna check bit number 7 in location number 66 in the address 66. If this is 1, I'm gonna go back. Go back. So as long as it is, so here what I did here, I'm gonna keep looping while bit number 7 in location on the byte at the address 66 is 1. Okay, guys, any questions? There is a small point here, guys. I told you, I want to make everything easy. That's what I'm saying. Here, it has to be a memory. It cannot be immediate value. It can be register memory. That's okay. Here, although this is a number, but actually we're not going to put hashtag. I'm not sure if the coder is going to accept hashtag or not. I don't think so. But anyway, you don't need to put here hashtag anyway. Why you don't need to put here hashtag? Usually we use hashtag, guys, because when like for example load. When I say 10, it can be address 10. So if you need a number, you have to put hashtag. So what you are putting here, it can be immediate value or it can be memory. Right? So that's why in order to differentiate between them, I'm going to use hashtag. Here, this is always a number, right? So it's not going to be memory location. So this one does not need hashtag here because there is no confusion. This is always a mask, a number. There is no confusion, right? But there was a confusion in case of load because when you say a 10, this 10, it can be a number or it can be address you want to read a byte from this memory location. So that's why we use hashtag 2. So anyway, any question, guys? Let me ask you a question. What if I want to loop when this bit is 0 instead of 1? I want to loop if it is 0. Very easy. I'm going to use here branch if clear. I have only 2 instructions: branch if set, branch if clear. So here I'm going to say branch if clear. If this bit is 0, go back. Is that okay? What if I want to check this bit instead of this bit? Very easy. Just to put the 1 here and make this one 0. Okay. What if I want to check 2 bits? Okay, that's easy. Okay, guys, any questions? Okay, so now let me tell you the conclusion before we move forward. The conclusion is we have 2 instructions. These 2 instructions, given a byte, I can check some bits, 1 or more bits, and then I can branch if these bits are 0s or 1s. Is that okay? Someone should ask me, or I have to explain why. Usually, I mean, if I have a byte, usually I'm interested in the byte, so I want to use the byte, the whole byte. So why sometimes, if you have a byte, I just want to check some bits in this byte? Why? Okay. For several reasons. can explain them right now. Okay, guys? So what I'm explaining, how can you use this branch here or set? How, right? Or in other words, why sometimes I have a byte, but just I want to check some bits. Why? Okay, so let me give you the first reason here. The first reason is, as you see here, guys, can you see these little switches? We have little 8 switches here. These are switches. Okay? This one, little switches. Okay. These little switches are connected to port H. Okay. So what happens, as I'm gonna explain in chapter 3, what's gonna happen is that port H is a byte. You are gonna read the byte. Is that okay? Where every bit is connected to one switch. Somehow, every bit is gonna tell you what is the status of the switch. As I'm gonna give you details how the hardware is connected. Okay, but forget the hardware. Now I'm gonna read port H. Once I read port H, so there is some connection between every bit here and the switch. Okay, that means if the switch is connected, here there is a 0. If the switch is open, this bit is 1. Okay, at any time when you change the status of the switch, this bit is going to change. This is something by the hardware. I'm going to explain later. Forget it for now. Okay, so again, as I'm going to explain in chapter 3, this is a microcontroller. Okay, we have a pin here. You have a switch. There is some kind of connection circuit here. There is some circuit, so that when you open it, you are going to put in the pin 5 volt. So in port H, when you read port H, every bit here has somehow connected the hardware. So every switch here or every pin should have 1 bit here, 1 bit. Is that okay? So the conclusion is that this is a very that's what we're gonna do in chapter 3. So what happens, guys, is port H is a byte. We don't have an instruction to read just 1 bit. What's gonna happen? I'm gonna read the whole byte, right? Then once you have the byte and you want to know if the switch is connected or not, you have to check the bits in this byte. You got what I'm saying? So I don't have an instruction to read 1 bit. No, what happens is that you are gonna take the whole byte. Even if you want to check 1 switch, you are gonna read the whole byte. After you read the whole byte, you can check whatever you want to check. So even if you're only interested in 1 bit, okay, or 1 switch, right? So you have to read the whole byte. So what's gonna happen, guys? I'm gonna read the whole byte. Then after I read the byte, I have to, for example, I'm interested in this switch. I don't care about the other switches. Okay, you can just check if this switch is 0 or 1. 0 means connected. 1 means it's disconnected, right? And then do whatever you want to do. So for example, I'm gonna use this switch to do something, to turn the buzzer on. So if it's connected, turn the buzzer on. Disconnected, turn the buzzer off, right? So here you need to check. Here again, guys, I'm gonna give you details for sure. What I'm explaining here, why sometimes you have a byte and you want to check some bits in the byte and you want to branch if this bits or 1s and 0s. This is a good example. We're gonna do it in chapter 3. What's gonna happen? I'm gonna read the whole byte and then I want to know if the switch here is connected or not, right? Connected, I'm gonna do something. Disconnected, I'm gonna do something else. So which instruction is going to help you here? For sure, we have branch if clear, we have branch if set. Branch if clear or branch if set. So this one is going to branch if this bit is 1 or 0. Okay, guys? Any questions? Let's have another example, and that's what you are going to need in the coming lab. I'm going to tell you what, I'm going to give you another example. Look here, guys. Another example, if you have a byte, and I want to check this bit, the most significant bit, okay? Then if this most significant bit is 0 or 1, if it is 0, that means the number is positive. Is 1 means the number is negative. So this is another example why sometimes I need to check some bits in a byte. You know what I'm saying? Given a number, how can you know if this number is positive or negative? Very simple. You can just check. You can check the most significant bit. Okay, guys. Any questions? Okay. Let Let me give you another thing, because that's what you are going to need in the coming lab. Look here. In the coming lab, I'm going to tell you, I'm going to give you, you are going to have an array, and I'm going to ask you to count the number of elements in the array, the number of even numbers in the array. The number of even numbers in the array. Is that okay? So if you have a number, how can you know this number is even or odd? Okay. I'm going to tell you the reason. How can you know? Actually, the first bit can tell you. If the first bit here means this is a least significant bit. So the least significant bit is 0. That means your number is even for sure. 1, it is odd for sure. Anyone can guess why? If it is 0, it should be even. If it is 1, it should be odd. What is the reason? Yes. I need answer from others too. I really appreciate what you are doing. So at least we can have some interactive teaching. That's okay. But I need more people, you know. So go ahead. Say it again. That's correct. Yes. Yes. So what happens, you know, in binary numbers, the weight of this one is 1. The weight of this one is 2. 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and so on. All these numbers are even numbers. All these numbers are even numbers. When I add even to even, also I'm going to get an even number. So the only way I'm going to get odd number when I have 1 here, when I add 1 plus even number. You can understand? When I add 1 to even number. Okay. That's why if here you have 1, that means this number is odd number. Okay. If you have 0, so this number should be even number, because I'm going to add 2. I'm going to add just I'm going to add even numbers together. Is that okay? Let me say it in a different way. Okay. What is the different way? I'm going to put it this way. I need someone to tell me why. Okay. I'm going to explain it in a different way. Look here, guys. I'm going to say if this bit is 0, so this number is divisible by 2. Divisible by 2. And because it is divisible by 2, should be even. You know that, right? If the number is divisible by 2, it's even. But why? If this bit is 0, this number is divisible by 2. Why? Any other students can answer? If this bit is 0, so I'm sure this number should be divisible by 2. Yes. Has to be an even number. It's divisible by 2. You know why? Because the 2 is going to be a factor. Okay, why? This one, this bit, if you take this bit, it has 2 plus 2 to the power 2 plus 2 to the power 3 and so on. So 2 is a factor. You got what I'm saying? So this is like 2 times 1 plus 2 plus 2 to the power 3 and so on. So that's why it should be divisible by 2. Because 2 is a factor. You got what I'm saying? Is a common factor. 2 is a common factor, so I can take it out. Okay. So using the same logic, tell me if it is 2. By the way, I can do it in a more complicated way. The easy way, if you want to check if the number is odd or even, the very easy way, just check this way. This is the easy way. Right? There is a difficult way. What is the difficult way? You can divide, as I already explained division in instruction. You can take this byte and divide it by 2. And then look at the remainder. If the remainder equal to 0, so this number is divisible by 2, or this number is even. You got what I'm saying? Okay, anyway, using the same logic, I'm going to tell you something. I need some student to tell me why. Okay? Look here, guys. Using the same logic. If the first 2 bits are 0, 0, so that means this number is divisible by 4. Okay, why? If the first 2 bits are 0, 0, okay, so this number is divisible by 4. Yes. You are right, but I want to make it easier. Okay, how you make it easier? 4 is a common factor. You got what I'm saying? Why? because this one, as you know, this one is 1, this one is 2, okay? So this one has 4, 2 to the power 2, which is 4. This one has 2 to the power 3. So this one has 4 as well. So if you add everything together, 2 to the power 2 plus 2 to the power 3, 2 to the power 4, and so on, you can take 2 to the power 2 common factor here. That's why you can divide by it, okay? So because it's a common factor, right? Easy. You get what I'm saying? Anyway, any questions? Okay. So again, the difficult solution, as I told you, you can just divide the element by 4, right? And then look at the remainder, okay? This is for sure difficult. The easy, just you can check only these 2 bits. But this is general, by the way. For what I explained right now, doesn't work for everything. For example, if I want to know the number divisible by 7, you cannot check bits. I think it's very difficult to check bits to know, for example. So here, this is a general case. So if I want to know if a number is divisible by 7, I can divide it by 7 and then look at the remainder. Is that okay? So in the coming lab, what you are gonna do is, you are gonna do, as I told you, you are gonna scan an array, and then I'm gonna tell you for count how many numbers are, for example, even, how many numbers are odd, and so on. So all what you have to do, you have to use this branch instruction experiment. So let me give you an example on what I explained right now. Okay. You know, before I give you this example, maybe I want to go back here to explain for loops. So I told you guys, if you want to make for loops, you have 2 options. You can use one of the loop instructions. I didn't teach yet, loop instruction, or you can use branch instructions to create for loop, guys. You have 2 options. Okay, for while you have only 1 option. For while loop, you have to create the loop by yourself, as I explained here. So in while loop, yeah, in while loop, I told you we don't have an instruction for while, so you have to use compare and branch instruction to implement to do it. However, for for, we have 2 approaches for for. Okay, one approach, you can use one of the loop instructions. Okay, I'm going to teach them. Or you can use compare and branch instruction. Okay, so I want to make a quick comparison between them. Unfortunately, this one's only short version. They don't have long version. So this, if you want to use this one here, they only short. There is no long. So you cannot branch too far, right? So this is one problem. For sure, this one is easy to use because this. You are going to use one instruction, it's not just going to do a lot of things. So this one easy to use, easy. You don't need to implement everything by yourself. Okay, so this one is easy to use. However, this one has 2 problems. Number 1, it has to be short. Okay, number 2, you know, if you the way you are going to do make for loop, guys, is going to be similar to the way we do it here in C language. We are going to have a counter, so we're going to do it the same way in assembly. It's the same way. I have a counter. This counter, I'm gonna initialize it, and then in every iteration, I'm gonna increment it, and then I'm gonna compare it to a condition. This is the way you're gonna do it in assembly. It's gonna be the same way like this one. Okay. So this counter here in assembly, it can be a memory location or it can be a register. Okay. So another disadvantage here. This your counter here, it has to be a register. It cannot be a memory location. Okay. But here, if you want to use compare and branch instruction, number 1, you can make it short or long, because you're going to just use branch. So you can make it with letter L or without letter L. Okay. So this is a good big advantage here. The other thing, the counter here, it can be a register, or it can be a memory location. So let me tell you the conclusion here, guys. The conclusion is that how can you make for loop in assembly? There are 2 approaches. In one approach, you can use loop instruction, or the other one, you can create it using compare and branch instruction. Okay. This one is easy to use, because just as you will see later, this instruction is going to do too many things. It's going to do three operations in one instruction, as you will see when I explain it. Okay. So that's why it's easy to use. However, this one has two main problems. The first problem is the counter has to be a register, not the counter, okay? Like I here, like I as I used here, okay? So this I, it has to be a register. It cannot be a memory location. Why this is a problem? Because we don't have too many registers. We don't have too many registers, okay? Here it can be a register, or it can be a memory location. This one only short, this one can be long or short, okay? So I'm gonna start with this one first before I go to this one. Okay? Yeah, look here guys. For example, this is how I can make for loop easily. Look here. I'm gonna make a variable. I'm gonna call it counter. You can call whatever you want to call it. You can call it I. So this one is similar to I we are using in for or J. We used to use I or J in for loops. So this is similar. Then I'm gonna initialize it with, for example, I'm gonna initialize it with number 10. And then look here, guys. Again, I'm gonna do the same thing with it in C. Number 1, you have a count. I'm gonna initialize it. Number 3, every iteration I'm gonna increment or decrement. Number 4, I'm gonna compare the condition if it is okay. So that's exactly what I'm doing here. Look here, guys. So I created a memory location. I'm gonna initialize it as you see here. Look here, what I'm gonna do. Now I'm gonna compare. Then every iteration I'm gonna decrement it by 1. So every iteration I'm gonna decrement it and then go back. So here I'm gonna compare it to 0. Once it is 0, go out. So I'm gonna start here from number 10, as you see here. I'm gonna start from number 10. Every iteration I'm gonna decrement it by 1, just to go out here. Sorry, come here. Then I'm gonna check if this one is equal to 0. Then go out. If not, just come this way. Yeah, I was about to say it. Okay, so it's a very good point. Where is the compare? So what you have to say here, compare A to 0. Is that right? This is redundant. Okay, if you want to make it, that's okay, but it's not gonna make a difference. Any guess? So if you remove it, we have to use compare. Okay, you have to use compare, right, in order to set the flags. But what I'm saying, this is redundant. You don't need it. But if you write it, it's not wrong. I'm totally fine. But it's redundant. You don't need it. Why? No, I didn't use compare at all. Just loop. I'm gonna loop counter to A. That's it. I'm gonna tell you what. Listen to me. Branch of equal of not equal. Which flag? This one is gonna check the 0 flag, right? Load is gonna update the 0 flag. So if the value you are loading here, if 0, so this one is gonna put 1 in the 0 flag. That's why I don't need to compare. You got it? Anyway, if it is difficult for you, you can just use compare. But what I'm saying, what compare is gonna do? Compare is gonna check A to 0. If it is equal to 0, it's gonna put 1 in the 0 flag. It has already been done. It has already been done by load. Because if you load 0, if you go to the instruction set and see what flags load is gonna update, load is gonna update the 0 flag. So if you are loading 0, load is gonna put 1 in the 0 flag. So load is gonna, because here this one is okay in case of equal, but in case of something else like greater or less, it may not work, right? Because in case of equal, I'm only interested in the 0 flag, right? And load is gonna update the 0 flag. Anyway, this is one of the very rare cases. I don't need to compare. It's just redundant. Okay. Anyway, that's very interesting. But I'm totally fine. If you want to make it easy, you just use compare. Also, I'm totally fine. But this is just redundant. You don't need to compare because here, this one, I'm looking for the 0 flag. Okay. This one is gonna put 1 in the 0 flag if A is equal to 0. That's exactly what load is gonna do. So load is enough. Anyway. Okay, guys. Any question? So let me just in one quickly. So this is how I created for loop here, guys. I'm gonna use a count. I'm gonna use a memory location. This is exactly like I'm gonna initialize it by 10. As you see here, in every iteration, I'm gonna decrement it. Then come back here. Then I'm gonna check. Once it is 0, go outside. Okay, so I'm gonna start from 10 until until 0. Once it's 0, so I'm gonna go outside. Anyway, so as you see here, what I did, I created for loop using compare and differential instruction and decrement the same idea. Okay, guys. Anyway, the coming Thursday, we're gonna have a quiz on this section. This section is very important. The coming lab very important. Please try to give it some time. Okay. So this topic is one of the most important topics. We're gonna use it all the time. So please study it. If you need any help, we're gonna help you during the lab. At any time, we can help you. But you have to do what you have to do, right? So you have to study it first. Okay. And you have to do the coming lab. Very important. You should understand it. Okay.